let's explore graphing equations via intercepts and symmetry. So let's sketch a graph of this equation using any intercepts, any symmetry this equation may have, and if needed, plotting some additional points. Using these, we should be able to come up with a good sketch of this graph. Let's start with intercepts. We discovered that to find the x-intercepts, we set y equal to 0, and then solve for x. So we have exactly one x-intercept. For the y-intercepts, we saw that we set x equal to 0 and then solve for y. So the equation becomes y squared equals 0 plus 9, y squared equals 9, which has solutions plus or minus the square root of 9 plus or minus 3. So we have a pair of y-intercepts. So we already know 3 points for our graph. Now let's check symmetry. So now let's see if our equation has any symmetries. And here's our equation. To check whether it has symmetry about the x-axis, we take our equation and we put in x comma minus y. So our equation becomes minus y quantity squared equals x plus 9. And this equation is equivalent to y squared. It is equal to y squared on the right. Equals x plus 9. So the resulting equation is the same as our original. So this does have symmetry about the x-axis. It may also have y-axis symmetry. Let's check. Here, we substitute in negative x comma y. Here's the original equation. We make the substitution. And we see that this equation is not equivalent to the original. How do we see that? Well, we can rewrite this as negative x equals y squared minus 9. So this is not equivalent to y squared minus 9 equals x, which is equivalent to our original. So the resulting equation is not equivalent to the original. So the answer is no here. Does not have symmetry about the y-axis. So this tells us that it will only have x-axis symmetry. But let's nonetheless check symmetry about the origin to go through the exercise. The reason why we can conclude that it will not have symmetry about the origin is because of this factor over here. If it were to have symmetry about the origin, then it would have all three symmetries. We already know that it has x-axis symmetry. So having two symmetries would imply that it has all three. We know that it does not have symmetry about the y-axis. Nonetheless, let's go through this. So here, what we do generally is replace x comma y with minus x comma minus y. So the original becomes this equation, which when we simplify, we get y squared on the right equals minus x plus 9. The same equation as in this check for symmetry about the y-axis. So there's the direct proof that this does not have symmetry about the origin. But we could have used this fact over here. So let's sketch the graph. The first thing we'll do is plot the intercepts. We have the x-intercept of minus 9 comma 0, and the y-intercepts of 3 comma 0 and minus 3 comma 0. We know that it has symmetry about the x-axis. So whenever x comma y is on the graph, then x comma minus y will be as well. Let's plot a couple more points. Here's our equation. And we see that to get a solution, let's try to find solutions where the x and y are integers. To get a solution where x and y are integers, we need to find values of x that make the right-hand side a perfect square. The perfect squares are these numbers. So we see, for example, to get 4, or let's see, how would we get 1? To get 1, we use x equals minus 8. And this would make y equal plus or minus 1. So for example, this is a solution to the equation. Minus 8 comma 1. And another solution would be trying to make x plus 9 equal to 4. So x is minus 5. Y squared equals 4, and we get the values plus or minus 2 for y. So for example, this is another point on the graph. Minus 5, comma minus 2. So symmetry tells us that this will also be a point on the graph. minus 5, comma 2. This is minus 5, comma minus 2. Symmetry also tells us that this will be another point on the graph. Minus 8, comma minus 1. Of course, we get that from solving the equation, too. So we see that when we connect these points, we end up with this sideways parabola. There's a sketch of the graph. Y squared equals x plus 9.